So this F is equal to mu S times the normal force. And just to give you a heads up, on a test or a quiz or that type thing, I usually would give you mu sub S and mu sub K both. And you're supposed to know which one to use. So in this case, I only gave you mu sub S, which really limited the choices.
So,
I-
oh, sorry.
Sorry, I know theta, I know mu, I don't know M, don't care. I know, I'm trying to find V. How do I solve this?
If we don't know m, do we use one of the equations set equal to m and then insert it in the other one?
That, no, it turns out the mass actually is irrelevant.
Okay.
So if I don't give you the mass in a problem like this, either you're solving for the mass or the mass doesn't matter.
So V should be,
So you can make up a number if you don't like the unknown aspect of it, and I would recommend using one.
so V should be the square root of y sine theta minus mu sub s y cosine theta times r over m.
That is true, but we don't know why,
We don't know.
the letter y, the normal force.
So do we substitute, set something equal to y, and then substitute that in?
That's one approach, yeah. So which equation do you want to use to solve for y?
The bottom one, because we have to insert it into the v squared one.
All right, so y, I can factor y out, so I get y cosine theta plus mu s sine theta equals mg. And so y is equal to mg over cosine theta plus mu sub s sine theta. And then sub it in, is that what you were going for?
Yeah.
I'm gonna write that view a little bit more legibly. So if we take this and plug that into here. We will end up with, I'm gonna erase this part. So I've got mg sine theta over cosine theta plus mu sub s sine theta equals, oh, no, sorry, plus mu sub s mg, oh, sorry, minus, looking at the wrong equation. U sub s mg cosine theta over cosine theta plus mu s sine theta equals mv squared over r. And if you're writing this stuff down, please check, make sure I didn't make a careless error. I'm not seeing an error at the moment. Okay. At this point, every term has mass in it. We can cancel out mass. And it has a factor of mass. We've got mass, mass, and mass all on the top. So that can cancel out. And so V is equal to the square root of R times, it's sine theta minus mu s cosine theta divided by, factor g out, over cosine theta plus mu s sine theta. I did skip a step there. I have two fractions with a common denominator, so I just added the numerators. Now we plug in numbers. That's 100, 9.8, sine of 70 degrees minus 0.6 cosine of 70 degrees. And then cosine of 70 degrees plus 0.6 sine of 70 degrees. And at this point, if you got that far, the biggest mistake I would think a student would make would be their calculators in radians instead of degrees. And then the next most common mistake would be flipping numbers when you're writing down the answer.
Wait, so is this like the answer that we're looking for to finish the problem, or are we not done with the
Yeah,
problem?
this is the minimum speed so that you don't start sliding down
Okay,
the 70-degree angle, the 70-degree split.
okay. Do we have to find V max?
Oh yeah, we're gonna find Vmax too.
Okay.
It will not be as much work. Because we've done the bulk of the work already.
How did we go from what was on that board to the top part of that equation?
All right, so two equations, two unknowns. I don't know V, I don't know Y, M is irrelevant. From this equation right here, solve for Y. So you're good with this.
Yeah, I'm good
All
with
right.
that.
So then just substitute that in for my Y's here. So I have mg over this denominator times sine of theta. So I end up with mg sine theta over that denominator. Minus mu s times that, times the cosine of theta. So mu s times the mg over this
Okay.
times cosine of theta.
Okay, so you're just substituting that top equation for y.
Yes,
From what
yes.
we got from the other. Okay.
Yep.
Makes sense. Thank you.
Yep.
If you're interested in velocity, it was 26.43.
I'll look over my glasses at you.
Meters per second.
26.43 meters per second.
Yes, sir.
Anybody else get the same thing? They believe in you. They trust you.
I mean, I don't trust me.
What is 26?
I was just plugging and chugging, so I don't know if I messed up plugging and chugging.
I got 28.19. I might be wrong as well.
I will sacrifice. I will.
And you also made a misspeak. What is this we just found?
Minimum speed before it starts sliding down.
Yeah, speed. You said velocity.
So it's not, it doesn't have a vector symbol.
Right. That means we got a ballpark number here.
$28.1889, yeah.
All right, so you got the second one?
Yeah.
And you got that as well?
It is my thing.
Hold on.
Degrees. My thing is in
Just leading us astray.
degrees.
What is 28 point? What would that be in meters per hour? Miles per hour?
Well,
Google it real quick.
very crudely, double it and add a little bit, so that'd be somewhere around 60 miles an hour.
Oh, okay. Yeah, makes sense. like a couple months ago, I was playing, I forgot what I was playing. But we were on the Nürburgring, and the Nürburgring has a banked part.
Okay.
And I couldn't maintain staying straight on there, because I was trying to keep speeding up. Because I thought, well, at the time, now I'm learning differently, but I thought that as I sped up, I would stick to it even more, because of
Yeah.
the car's downforce. But no, the more you speed up, the more unstable the car becomes. But if
Ah.
you slow down it also. So when the question came up, that's what I've been thinking about the whole time.
Okay.
Now I get it.
Well, we'll find out the maximum speed, because there's gonna be a range there.
Right.
So it depends on, I guess, where you were in the range. I had a summer job at IBM when I was in college, and driving home, there was this rather sharp turn, and my goal was to be able to take it at 45 miles per hour. And had difficulty, in doing that, because there's that certain point where suddenly, I'm doing this. And
Yeah.
I realized, I eventually figured out how to do it, is that when I hit the curve, speed up, because that will press me into the seat, and I'm not gonna be doing that, so I stay right in front of the wheel the entire time, so I could actually have more control.
Was it front wheel drive? That would make sense.
I think it was.
Cause in like in my car, since it's all wheel drive, in a curve like that, I would actually slow down and then make a little angle, and then I throttle through.
Ah,
What car was it? Do you remember?
that's, what tire?
Yeah, like what car were you driving?
It was a Ford POS.
Was it a Pinto?
Yeah, that's what I thought.
Ford Tempo. Did you say Pinto or Tempo?
Pinto.
Tempo.
Oh,
It was a
okay.
Ford Tempo. It was they made a whole slew of them, I think primarily for rental and for students who couldn't afford it any better.
Oh, trusty.
All right. We solved half the problem. Any questions on this before we solve the other one? I am gonna use the magic of the eraser to do the other one. Because I'm not gonna erase the whole thing. I don't have to. Because we've done most of the work. Now, the only thing that changes, besides we're looking for this, we're looking for that maximum speed. So if I exceed the maximum speed, I'm gonna start sliding up the ramp. So what changes in my force diagram?
Your desired, your friction, your desired motion.
Friction is now down the slope. And there it came up. Weight, normal force haven't changed. Friction has switched directions, which means that that was, I lost track. That was minus before, so that's now a plus, that's now a minus. That is what's changed, and I should do that in a different color just to emphasize the change there. Yes, that blue really jumps out amongst that.
Yeah, I was like, okay, really helps out. That seemed better for all the colorblind people.
So this is coming from the second equation right here, so that should be a plus now. That should be a minus. This is from this equation right here, so that should be a minus.
Should.
Then make another.
Well, I don't know if it really matters, but that W, should it be a plus now?
No, weight is still down.
Oh, yeah, my bad. Or friction's in.
Yeah, friction is the only thing that's flipped. And so I'm gonna solve it a little bit differently. This is the way we did it before, just to show you a different way of doing the same thing. I'm gonna, from these two equations right here, I'm just gonna factor y out. So I have y times sine theta plus us cosine theta is equal to mv squared over r. The other equation, if I factor y out, I get y cosine theta minus mu s sine theta is equal to mg. And now I'm just going to divide. I'm gonna divide the left-hand side and divide the right-hand side. Because the math people insist, as long as you divide by the same number, not zero, it's legitimate. Well, since these are equal, I can divide the left by this, and I can divide the right by that. The y's cancel out at this point, the mass cancels out, and I'm left with sine theta plus mu s cosine theta over cosine theta minus mu s sine theta. Is equal to v squared over gr. Then if I multiply both sides by gr, take the square root, that becomes plus, that's minus, plus, minus, and we end up with this v min. See more people with calculators out now.
I'm just still writing it down.
Your answer. Ready? Ready? Yeah.
Nah. I'm doing something wrong. So I was double checking to make sure.
I got 51.24. Speed in meters per second.
Confirmation? Or are we just gonna trust them this time?
It worked out well last time.
He's just off by 2 meters per second. Come on, that's not much. And the bridge collapses.
And the bridge
At least, you know, realistically, if you're building a bridge, you have so many extra factors in there that, you know, this is what we expect, so then multiply by 2. So, I mean, the building codes are very strict on that. But if you're designing fighter jets, yeah, you have those numbers down pretty precisely.
I hope so.
I got 50.58, but I'm not ready.
Now, that could potentially be a rounding difference. Did you both just leave it as cosine and sine of whatever number you got, or did you round that off?
No, I inserted that equation into my
Okay.
calculator.
That's what I did too.
Okay, all right. So we got a tiebreaker here?
Somewhere in the middle.
I would just like to say that I put parentheses around my sine, like my sine 70 plus 0.6 cosine 70. I don't know if anyone else is doing that. That would change the answer.
Parentheses, the better.
Just say.
Let's see if
Feel the excitement. Place your bets now before we figure out what the real answer is.
yeah, I'm trying. I did not put parentheses.
Ah. Is that a look of satisfaction there, Pam?
A little bit.
You got neither of them? That's a look of.
For some reason, I'm getting a negative number.
Oh, yeah,
for
same.
the-
-5.161.
Yeah, that's what I'm getting for the like, times 9.
So you got a negative under the radical?
Yeah.
That's what I'm getting as well.
So let's see, what would that mean?
Degrees radian calculator.
Possibly a degrees radian issue.
I am in degrees.
Oh, wait. You got a negative in the
Yeah.
denominator?
Cosine 70 minus 0.6 sine 70
No.
is a negative.
Cosine of 70 is a positive number.
Yeah, but minus that is.
Oh, what is cosine of 70 degrees?
0.34,
And sine of 70 degrees?
0.939.
Are you supposed to be?
0.6. It's gonna be bigger than that, so, alright, so we do end up with a negative here.
Wait, do you just?
Make gravity negative.
I was using that equation right there, not that one.
You're using this equation?
Yeah, that's why I was getting my negative.
Oh, I was using that.
I was using that one.
I was using the wrong one as well.
Well, I mean, it comes from it.
Yeah.
Alright, so, a negative under the radical. Two interpretations. What are they?
One of the directions is wrong.
Okay, we made a mistake in
The-
general.
The negatives will cancel out. In terms of what's on the top.
No, the
Well, I
only
mean,
negative is,
in theory.
so we made a mistake or,
I think that we can't calculate it.
yeah, those are the two choices.
Okay.
So, let's run back through. Actually, why don't we, at this point, take a break and let me see if I can figure out whether, if there is indeed a mistake or.
Oh, non-real answers. Oh, great.
I got 71.1.
Well, yeah, cause you have a negative under the square root.
Ah.
Maybe it won't be.
Yeah.
And that got
I feel
a lot.
like there's a mistake somewhere as opposed to it's not solvable.
It's on my belt.
All right, we're rolling again.
I had 8 classes.
All right, I don't think there's an error in what we've done. I think it's that there is no maximum speed.
There is no maximum speed.
Like,
Can you explain how there is no maximum speed?
yeah, say that.
Doesn't make
Well, let's just plug in numbers. Let's see if we can break it. Let's say 1,000 meters per second. If there's a maximum speed, I'm willing to bet 1,000's bigger than the number we want. So if we do that, that